Hello friends, this is the Westcoast Math Tutor. Today we are going to look at Newton's law of cooling. This law states that the temperature of a heated object, like a cup of hot coffee, decreases exponentially over time toward the temperature of the surrounding medium. Long story short, the temperature T of a heated object at time t is given by T equals C plus T0 minus C in parentheses times E raised to the power of K times T, where C is the constant temperature of the surrounding medium, T0 is the initial temperature of the heated object, and K is a negative constant that is associated with the cooling object. Let's work on an example to make these things clear. A cake removed from the oven has a temperature of 210 degrees Fahrenheit. It is left to cool in a room that has a temperature of 70 degrees Fahrenheit. After 30 minutes, the temperature of the cake is 140 degrees Fahrenheit. Use Newton's law of cooling to find a model for the temperature of the cake T after T minutes. The initial temperature is 210 degrees Fahrenheit because that's the temperature when the cake is removed from the oven. The constant temperature of the room is 70 degrees Fahrenheit. And after 30 minutes, the temperature of the cake is 140 degrees Fahrenheit. We are going to substitute these four values into Newton's law of cooling. So we can write 140 equals 70 plus 210 minus 70 in parentheses times E raised to the power of K times 30. Now we can find K, the negative constant. 210 minus 70 is 140. And after subtracting 70 from both sides, we get 70 equals 140 times E raised to the power of K times 30. Now we are going to isolate the exponential factor by dividing both sides by 140. "70 divided by 140 is 1/2, because 70 divided by 70 is 1, and 140 divided by 70 is 2. And 140 divided by 140 is 1, so what's left over on the right side is E raised to the power of K times 30. And after taking the natural logarithm on both sides and using the inverse property, on the right side, we get ln of 1/2 equals K times 30. And after dividing both sides by 30, we get approximately the negative of 0.0231. Now we substitute the negative of 0.0231 for K into Newton's law of cooling. So we get T equals 70 plus 140 times E raised to the power of the negative of 0.0231 times T. Let's look at B. What is the temperature of the cake after 40 minutes? To find the temperature of the cake after 40 minutes, we just substitute 40 for T and evaluate to find T. So we can write T equals 70 plus 140 times E raised to the negative of 0.0231 times 40. Typing this into the calculator gives us approximately 126. So after 40 minutes, the temperature of the cake will be approximately 126 degrees Fahrenheit. Let's look at C. When will the temperature of the cake be 90 degrees Fahrenheit? To find when the temperature of the cake will be 90 degrees Fahrenheit, we substitute 90 for T into the cooling model and solve for T. So we can write 90 equals 70 plus 140 times e raised to the power of the negative of 0.0231 times t. And after subtracting 70 from both sides, we get 20 equals 140 times e raised to the power of the negative of 0.0231 times t. Now we are going to divide both sides by 140. Which gives us 1 over 7 equals e raised to the power of the negative of 0.0231 times t. We get 1 over 7 here because 20 divided by 20 is 1 and 140 divided by 20 is 7. And after taking the natural logarithm on both sides and simplifying the right side using ln of e raised to the power of x equals x, we get ln of 1/7 equals the negative of 0.0231 times t. And after dividing both sides by the negative of 0.0231, and typing this into the calculator, we get approximately 84. So the temperature of the cake will be 90 degrees Fahrenheit after approximately 84 minutes. This video is what I did for you. If you want to do something for me, hit the bell button, like, share and subscribe. Thanks for watching and happy learning everyone.